Good morning, good evening, wherever and whatever you may be. I'm SpiderDevice, and welcome to Web Talks. This is Web Talks Episode 2, The Formula Part 1. Now, before we begin here, I would like to tell you about another channel that is doing a similar video series to mine. This channel is called The.Amazing. I don't know if it's actually just The Amazing or not, but they are also doing a similar video series to this, talking about their web shooter designs, real web shooter stuff, and they've showed their own web shooter designs that they've built. So if you are actually interested in making this project, I would encourage you to go ahead and check out that channel, as well as keep watching the Web Talk series, as well as their series. You can find the link to that channel in the description of this video. But without further ado, let's go ahead and start talking about the formula. So this episode is going to focus mostly on the properties of the formula. The next formula episode in the Web Talk series will discuss the formula components and ingredients. Let's get started. So the first thing we should probably establish is what we want the formula to accomplish. There are a lot of different forms the formula can take, and as one would expect, this form not only depends on the composition of the web fluid, but also on the other parts of the shooter. So for this episode, we'll just be taking a look at the formula itself and the basic properties it should have to achieve a web-like form factor. Now this of course does heavily depend on the spinneret composition. If you want to learn about the construction of the spinneret, watch my previous Web Talks video, which discusses the spinneret. Let's move on. So let's start off by talking about my channel name. Yes, I know this is a bit weird, but bear with me here. If you read my channel description, you'll see that this channel, basically my name now, is SpiderDevice for a very specific reason. This reason is that the device I've been working on is called the SpiderDevice. Now while the obvious connection remains here, this name is actually an acronym created by the White Widow, a fellow member of the superhero hype forums where I got into the web shooter project. The SpiderDevice means SPIDER. Strong polymer is drawn and extruded rapidly. SPIDER, spider. We can start looking here for what the formula must do. First off, the formula must be strong. Well, what exactly does that mean? The exact property we're looking for here is tensile strength. Tensile strength is a measurement of stress a system or substance can take before breaking or failing in some way. This is measured in units of pressure, such as megapascals or newtons. This specifically comes into play when we look at the line form factor of web. And since this is the most recognizable and sought after by Spider-Man fans, I figured it would be the best place to start for the formula series when we actually get into the different form factors of the fluid. So we already went over the spinneret, and how the spinning mechanism and the joint members of the web line will increase overall tensile strength. We also talked about a few scenarios where the formula would directly interface with the spinneret mechanism. However, we really didn't talk about the properties of the formula that would be present in order for the form factor of the web to exist. Anyway, the next part of the spider name is P for polymer. Now, what exactly is a polymer? Well, without getting too in-depth for fear of losing anyone's attention, we can say that a polymer is a chain of the same molecule over and over and over. Here's an example of what I mean. Now, bear in mind, this specific example of a polymer is not actually one that would be used in the formula, but it is a good example of what a polymer structure looks like. As you can see, the germanium atom connected to the methyl groups on the top and bottom repeats over and over and over again, perpetually, bonding to other identical atoms. This forms a polymer chain, which has reasonably high tensile strength. Once again, I'm referencing polymers in general for the project, not this specific one, as this one will not be used in the project. But before we go into the polymers that are actually most plausible for the web shooter project itself, let's go over the rest of the name of the spider. IDE is the next section of the name spider, and it represents is drawn/extruded. We already talked about a substance being drawn or extruded in the previous episode, but the next part of the name is absolutely vital. The R. This means rapidly. When looking to extrude the substance rapidly, we have to take a look at a few factors, namely the viscosity of the formula and the shear properties of said formula. Let's first take a look at the factors that affect viscosity. Now, one of the major things that affects viscosity is the formula's solvent. Now, the solvent is not a component that I would always have to be included. However, it is included in many formula iterations that I and many others have created. It is one of the most common ways to create a formula. Effectively, what a solvent is a substance in which the other components of the formula can dissolve. The actual viscosity of the formula, while dissolved, should be fairly close to the viscosity of the solvent. Now, in the context of the formula itself, the way that my old formula worked was that the solvent and the other formula ingredients would be mixed already in the pressure vessel. Then, as the formula was ejected from the spinneret, the solvent would evaporate, leaving the rest of the wet formula to work its magic. Now, I'm not saying that this isn't an effective method at all. If it wasn't, I wouldn't have used it for so long. However, the method that I'm going to talk about now is the one that applies to my current formula, this formula. Now, instead of having the solvent evaporate when the fluid leaves the shooter, imagine if the solvent, or some other ingredient on its own, or mixed with the solvent in the wet formula, allowed the formula's viscosity to vary depending on the pressure applied. If this sounds familiar, you're probably thinking about a non-Newtonian fluid. Now, I remember back when I traveled to the Pacific Science Center in Seattle, and also when I was in one of my middle school science classes, we did some experiments with non-Newtonian fluids. The one that we looked at was colloquially called GAK, which contains glue and soap. I'll leave a link in the description to this fairly elementary procedure. This substance, GAK, is usually used to introduce students to the properties of non-Newtonian fluids and polymers. In fact, it's the exact analogy that I'm making now, as I'm sure that at least one of you has encountered this substance or experiment before at one time or another. Now, with this substance, those of you who have done the experiment would know what happens when you simply lay this substance out on a table. It will start to drain away from the centroid of the mass that you place down, just as a liquid would do when placed on a flat surface. However, applying pressure to the fluid at some point will cause the fluid to act as a solid would, thus making it non-Newtonian, as it does not act solely as a liquid or solid. Now, this is, of course, the essence of shear thinning or shear thickening fluids, which are both types of non-Newtonian fluids. A shear thickening fluid, like the GAK substance I mentioned before, will thicken when a shearing pressure force is applied to it. Now, make no mistake here, this doesn't mean that the diameter of each member thread will increase as the formula is ejected. That's what I immediately thought when I first heard the term shear thickening, but I was corrected immediately after I heard this term. What it really means is that the formula's viscosity will increase, as in the fluid will thicken, so to speak, as the shearing force is applied. The same sort of logic, of course, applies to shear thinning substances. As a shearing force is applied to the substance, the viscosity will decrease. Now that we've gone over a bit of what the solvent and shearing properties entail, let's answer the main questions that arise from this. The first question covers both the formula properties. Which property would be better to have in my formula? Why should I choose one instead of the other? Should I have a shearing property for my formula, or should I use a solvent? Now, this isn't something that has a completely straight answer. This really depends on the construction of the shooter and what your constraints are therein, like what materials you have access to and what your budget is. However, I can say that whether you choose a shearing property or the solvent method, assuming your shooter is built to accommodate that, you can't really go wrong. But the question is, what if you use both? What if you have a formula that, while the solvent is still present, is shear thinning? Then it becomes a liquid as it is ejected from the shooter. At this point, the solvent would evaporate from the condensed form of the fluid, leaving a strong and dried polymer chain behind. This is a perfectly viable method. It's fairly effective. It is, in fact, the basis for my new shooter, WDM 3.0, which I'll be showing you soon in Project Update 5. Now, the next question I'm sure I'll get is this: what solvent would be effective for my formula? Now, when it comes to my experience, there are 5 sort of universal solvents, as I like to call them, that would work in my experience. The first of these is water. Water doesn't dissolve everything, but it is a good enough solvent, and dissolves a good enough number of things that it is usually my starting point when I'm looking for a solvent for a certain substance. The next is denatured alcohol. Now, I've mentioned this in some of my previous project updates. It was the solvent I was using for my previous shooter, along with acetone earlier on. Denatured alcohol is similar to water. It does dissolve a good number of things. Not everything, but it is worth giving a look if water doesn't cut it. Usually the final solvent I'll look at is acetone. Acetone has a reputation for being able to dissolve a lot of things, especially plastics and polymers. on the forums and everything, I've been talking about how acetone is the ideal solvent because it evaporates quickly and it can pretty much dissolve anything. Now, on the fact of dissolving anything, I decided that I would just take some acetone and put it in this tank and just run it through the shooter to see what would happen, see if it could handle it and everything. But it seems that the tape that I put here and here started to dissolve. Basically, this whole thing burst, and as you can see here, it started to dissolve actual casing of the shooter. So I decided that I'm not going to use acetone anymore. I'm going to use denatured alcohol. If you have access to some acetone that's fairly close to pure or fully pure, this would be probably the best option for your solvent. Now, there are two other so-called universal solvents that are more effective than acetone, but I won't mention the names of them, considering they aren't really viable unless you're working in a laboratory environment anyway. Plus, you wouldn't be able to get any unless you were working in a laboratory environment. So they're not really worth mentioning by name. Now, the final question I would expect to be asked is, what substance should I use to get a shear thinning property or shear thickening property for my formula? Now, this question I won't answer now because I'm going to be answering it in the next Web Talks video. Now, that about wraps up what I wanted to talk about in this episode of Web Talks. The next episode will be Formula Part 2, which will pick up where this episode left off and fill in the holes from this episode, as well as talk about the basic components of the formula in relation to the form factor that one would be looking to achieve. If you have a suggestion for future episodes of Web Talks, or a question pertaining to the basic properties of the web formula as was discussed in this video, go ahead and leave a comment below this video with your question. I'll either answer your question in a comment response, or if I feel it's substantial enough, I'll answer your question in one of my periodic question and answer videos for the Web Talk series. But with that, I hope you enjoyed and learned something from this episode of Web Talks. Thank you for watching, and I hope to see you next time. SpiderDevice out.